Hello, everyone. My name is Yashas from Team 18221 Med Infinity in Trumbull, Connecticut, and welcome back to today's episode of Metacast. Today, we are joined by a member of Team 18661, Aniket. We're going to be going over the differences between Android Studio Java and blocks programming for FTC teams this year. Without any further ado, let's get started with the podcast. So, Aniket, what's the difference in accessibility when using blocks versus Java for FTC?
So, what I think the difference in accessibility between blocks and Java, first of all, there's the obvious characteristics of blocks way easier. It's way easier to use. One thing that's like very standard is that it's very similar to Scratch, and it's built so that as many people who are like just getting to coding can actually use it. So I think that's a big plus for blocks. Java can be a little bit daunting when you start at first. However, I think as you go on, you can get more familiar with it. So I think it does like they do converge at one point. So I definitely recommend using blocks first as an introduction to code, but I would recommend eventually switching over to Java, as we'll talk about later. It just there's more functionality, it's more versatile, and it's more used in the actual like workplace.
Yeah, of course, of course. So, moving on, kind of tailoring off from that question, what software functionality is exclusive to blocks versus Java? Like, what APIs or different browsers or applications will you use to access either of them?
So I think the biggest thing difference is source control. When you're using Java, you have access to tools such as GitHub, GitLab, Gitbucket. You can essentially use those to store different versions of your code. And I feel like that's the biggest like upside of Java. You can just have infinitely many variations of your code, and you can have different people working on different instances of the code, and without having like the worry of somebody's going to mess something up and delete all your work. There's this element on blocks as well. However, it isn't as intuitive and it can be a bit cumbersome because I believe that it's basically copying like a project op mode, and then like it's a little bit more like involved. Rather with Java, you can create a new branch with GitHub, do your stuff. Eventually, you can merge it back to the main branch, solve any merge conflicts. Very intuitive, and I feel like it's very good that you use Java if you're going to be using like tons of different functionality all over the place. That if you don't want to test it at the same time, like for example, if you're testing a drive in a manipulator, uh, there's multiple variables in that when you're testing. So usually our team we split that into two different branches so that the testing is done individually on the branches. And once that functionality is confirmed, we can merge both of those branches into the main branch. Other functionality that is usually more like exclusive to Java, what I'd say is like vision, like especially in like more recent years with OpenCV, it's like much more intuitive. Like although the new Vision Portal blocks does have some of the new April tag functionality, I feel like Java is just more suited to custom pipelines. Like especially for prod detection, it's just like unrivaled. One thing that blocks does have the upper hand, it's like I think if I recall correctly, when you're actually using blocks, you have access to like certain functionality like you can't get on Java, or at least it's a little bit more complicated to do on Java itself. So I think that's a big plus for blocks. But overall, I'd have to say that Java has more functionality, as it just lets you customize so much more.
Yeah, definitely. Um, Next up, what are the differences in pushing code to the robot when using blocks versus Java? So, once you're done writing the code, how do you actually make sure the robot has the code to run?
Okay, so I'll talk with blocks first. So first of all, the way you set up blocks, you connect to the robot. There's a URL. You connect to the Wi-Fi. You have your code. It's pretty intuitive actually how you push. You can essentially just there's a button once you have your stuff. Push code. Your robot restarts, and you should be good to go. Very simple stuff. It's very clean. I like it a lot. For Java, it's a little bit more complex because you do it through Android Studio. Essentially, once you're connected to your robot by Wi-Fi or you plug it in through USB-C, you can see the device list when you're pushing. It'll cut like to Rev Control Hub, and once you see that, you can actually just press push. It does, from my experience, it does take a little bit longer than pushing for blocks. I think that's just a side effect of how much more stuff there is in the Android Studio project than with blocks. So I think it's okay. And generally, when once you've actually done your interaction, the robot, the control doesn't actually do anything different from blocks or Java. It still restarts. You need to wait for the green light to come on in the expansion hub, driver hub, I mean the control hub, and you should be good to go. Overall, I think it's pretty comparable, but I'd have to give blocks the edge in this category because it's just much simpler. You press a button.
Yeah, 100%. I've definitely noticed that when pushing with blocks is much quicker and much more efficient than with pushing with Android Studio. Next up, what features are easier to implement on blocks, or what's easier to implement on Java? Are there different features that are better for blocks or better for Java?
So I think this is a very interesting question. I'd honestly say that there's a lot of overlap. Obviously, in past years, I'd had to say that Java Vision was just much easier to implement. However, with the introduction of the Vision portal and all the stuff that first is done to make it easier for blocks, I'd honestly say it's more even ground now. One thing that I'd like to say that it's easier on Java to do. Java, it's much easier to divide up your code. It's much easier to organize your code. I feel like while this isn't directly a feature, I'd say that it's very integral in like making your code more readable. Whereas in blocks, you kind of have everything in a stack, and it gets a little bit complicated over time. What actual like functionality, like features that are easier to implement? I'd say that PID controllers are much more easier. It's more intuitive. You write a simple loop command, and you just it's good. Um, One thing that I'd like to give the blocks, however, it's much easier to implement, is what I would say is just like joystick commands. It's very simple to get a variable assigned to a joystick, and getting that to influence your robot. It's much simpler. How I'd say Java when you do that, it you have to. It's much easier with FTC lib. However, with the stock experience, you have to go through the op mode, the inherent implementation of Gamepad 1, Gamepad 2. It might get a little bit like, it might be not as intuitive as blocks, but I'd say both are generally around the same area. Yeah, so I personally think that blocks in Java were pretty comparable with the joystick commands. How I think blocks just get a bit of an edge. I personally say that overall, there's more features in Java that are easier to implement, especially more complex features. But I'd say the more simple features are much easier to implement on blocks.
Yeah. Next up, how do blocks or Java and Java cultivate skills in software development for people in the future?
So, like I said earlier, using Java cultivates the skill of source control. It's very important. If you're working on big projects, it's very important that you have different branches to separate out your code. I think that's the main reason why teams use Java. Because, well, the main reason teams should use Java is because of the experience it gives you with source control. It's very important. One thing that Blocks does prepare you for, it prepares you for how to use Java. In fact, using blocks teaches you the fundamentals of how code works, the logic behind it, puts it in a very straightforward like format. I feel like if you use blocks, you can very easily transition to Java because much of the logic is the same. It's just a different format.
Yeah, 100%. Moving on, how do you think a team best can transition from blocks to Java or vice versa?
So I personally think that teams who are completely new to programming for FTC should start out with blocks for at least a season, unless they have prior Java experience. I'd say use blocks, understand the fundamentals behind the code, not just how like what the blocks do, what they are, what do they actually like mean, what do they represent, what structures can they create, and once you understand that, I think you can really truly understand how to implement those into Java. Once you transition, you're like at a point where block coding isn't it's limiting your functionality of your code, your robot. Say transition over to Java. It requires a little bit to set up. You need Android Studio. You need I think the FTC robot controller library. Once you get that, you should be ready to go. I think you need the latest version of Java as well. Um, I need to double check on that. But if you do that, you should be set up. Much of the code is the structure of the code is the same. While in block code, you write individual op modes. Java, each op mode is kind of like a main file in itself. So you can have different classes for your ARM, your slides, your drive. You can import that into your different op modes. So that is a little bit different from blocks. I don't think there's a functionality for that. However, I think one of the things that can really help transitioning from blocks to Java is just learning basic Java itself. If you just go into a new programming language like completely fresh, you're not going to understand the syntax, the organization, to like the proper like skills, like how to write good code, how to comment. You need to know the basics of Java first. I'd recommend going to W3 Schools. It's a very good resource. Basically teaches you how to do very, very basic Java. Once you get the very fundamentals down, you're ready to succeed for FTC because much of it is just using those basics and applying them to custom objects, custom like functions. I feel like once you get the hang of that, you'll definitely like be ready to go in terms of code with Java. And it'll let you do a lot with your robot that you couldn't previously do before. Like say, Roadrunner. Roadrunner is a very good application of this. On Roadrunner, you can essentially like create your own paths and stuff. And I think this is only for Java. I'm not sure if they have a version of that for blocks. It allows you to essentially like make your own custom like trajectory. It's very, very cool stuff. And like the way it's formatted, it's very suited to the Java infrastructure. You essentially create these paths, you can keep them in a separate file, you can call them in your autonomous op mode, the robot can run through them. It's a very, very sleek, very simple. And I feel like using stuff like Roadrunner, OpenCV really helps develop your skills. And I think using Java in general, use transitioning from blocks to Java lets you use these more complex like applications, something that can elevate your robot functionality.
Yeah. Um, and then finally, before we end the podcast, do you have any final thoughts on the debate between blocks and Java? Any comments? Any tips for teams?
Yeah, yeah. So one thing I'd like to state before leaving is that it doesn't really like matter. If you like blocks, you like Java, nothing's gonna stop you from doing it. Even if you don't have much experience in either of them, I'd suggest you try them both. Especially if you're on the fence, you have some people with skills in Java. However, you yourself aren't like really enthused about like all the complications that might occur. You want something that's simple, something sleek. Maybe it's your rookie team and you're just looking to get something, a robot that can work. Definitely Blocks is a good idea for that. In fact, our first rookie year, we got all the code for our robot done in a single day with Blocks. That was really very helpful because we were a new team and we were going to focus on our robot design. So having code out of the way was very helpful. However, if you're looking to get like to the next level, you want to try vision processing, you want to try autonomous complex paths, you want to try like dividing your code up in different systems. That's where Java really shines. Like if you're going for like high performance, Java is really the key to that. It allows you to do so much more than block.
Yeah, great. Thank you so much, Aniket, for joining us today. I hope you have a great season. And thank you, everyone, for tuning into this episode of Metacast. And I hope you all have a great day. Tune into more next week.
Thank you.